Okay, in the previous lecture, we finished first question in this example, and we found f sub xx, f sub xy, f sub yx, and f sub yy for this function, which is x squared times y times e to the power y. We found these second order partial derivatives. And now we have the second one. It says if z to be sine 3x plus 2y, show that 3z sub yy minus 2z sub xx equals 6z. That means here you should find second partial derivative for z with respect to y, and also second partial derivative for z with respect to x, and then we plug it into this function, into this equation. And the right hand side must be equal to the left hand side. Yes. So our function is z equals sine 3x plus 2y. We should find the second partial derivative for the function with respect to y, and also second partial derivative for the function with respect to x, and then we substitute the results here, and both sides must equal. Let's check. As we have given, the function is sine 3x plus 2y. So the function is z equals sine 3x plus 2y. Let's check. Yes, that's it. We are going to find the first and second partial derivatives with respect to x and y. We say z sub x means taking the partial derivative for the function with respect to x. The derivative of sine is cosine. Cosine 3x plus 2y times derivative of the angle. In the angle we have 3x plus 2y. 2y is a constant, so its derivative is 0 because we take the derivative with respect to x. And derivative of 3x is 3. So it equals 3 cosine 3x plus 2y. Then we are going to find this z sub xx. Z sub xx equals. To find z sub xx, we should find the derivative for this function with respect to x, because this is z sub x. If we take another derivative with respect to x for this function, we get z sub xx. So let's find z sub xx. The derivative of cosine, here we have 3. And derivative of cosine is minus sine times minus sine 3x plus 2y times derivative of the angle. The angle is 3x plus 2y. Derivative of the angle with respect to x is 3. And it equals minus 9 sine 3x plus 2y. This is z sub xx. And also, we should find z sub yy. Yeah, this is z sub xx. Look, in the equation that we should show that both sides are equal, we have z sub xx, z sub yy, and also z. So we found z sub xx, and you should find z sub yy, and this is z also. To find z sub yy, here we are going to find z sub yy. First, we should find z sub y equals to what? We are going to find the derivative of z, this one, with respect to y. Okay, so the derivative of the function with respect to y, we have a sine function. Derivative of sine is cosine. Cosine of 3x plus 2y times derivative of the angle. But here we take its derivative with respect to y. So x terms, in the first term, you have no y. So its derivative is 0 because we treat with that term as a constant. Times derivative of the angle is 2. So it equals 2 cosine 3x plus 2y. Okay? And then to find z sub y, we say it equals, we are going to find the derivative of this function. This is z sub y. To get z sub y, we should take another derivative and the partial derivative for the result for zy with respect to y. So you get 2 times derivative of cosine is minus sine. Minus sine 3x plus 2y. Then multiplying by derivative of the angle with respect to y, and it's 2. It equals, so here we say z sub y equals minus 4 sine 3x plus 2y. This is z sub y. So we now have z sub xx and z sub y. We substitute these into this function, into the given equation. 3z sub y minus 2z sub xx equals 6z. We have 3z sub y minus 2z sub xx equals 6z. Is it? Yes. You say this is equation, let's say it's star. We substitute z sub y and z sub xx in star. Let's see what we get. Here we have 3 times z sub y. This is z sub y. We just multiply minus 4 sine 3x plus 2y by 3. So you get 3 times minus 4 sine 3x plus 2y. Then minus 2 times, this is 2 times z sub xx. Z sub xx is minus 9 sine 3x plus 2y. Minus 9 sine 3x plus 2y equals 6 times z. And z is sine 3x plus 2y. That's z. Let's check. 3 times negative 4 is minus 12. Sine 3x plus 2y plus 18 minus 2 times minus 9 is plus 18. Sine 3x plus 2y, it equals to 6 sine 3x plus 2y. And here the left hand side, in the left hand side we have minus 12 times sine, and also 18 sine. Both angles are equal, so you can add or subtract, and you get 6 sine 3x plus 2y. It equals to 6 sine 3x plus 2y. That means left hand side equals to the right hand side. It's only taking derivatives and then substituting in the equation. And we showed that, or proved that, the left hand side equals to the right hand side. Is that clear? Only taking derivatives and then substituting into the given equation, you get the result. Now we have Euler theorem. We say the Euler theorem says if f here we have Euler theorem. It says if f sub x, f sub y, f sub xy, and f sub yx, if these partial derivatives are continuous and defined in an open space that contains a point AB. That means if these all functions, these all are functions that you get from the function of f. These are partial derivatives of f. We say if these all functions are continuous and defined in an open space that contains this point, if this point is in the space, then we say f sub xy at the point equals f sub yx at the point. That means if those functions are continuous and defined in a space, then if we pick any point from the space, then the function at that point, if for the partial derivatives of that at that point, f sub xy equals f sub yx. We can change the order for the continuous functions. If it's not continuous, we cannot do that. Okay, for the continuous functions, f sub xy equals f sub yx. Let's say an example. I'm going to write down an example here. Let f of xy equals let's say x squared sine y squared. This function is continuous at all. Is it? At every point of xy is continuous. So f sub xy, we are going to find f sub x1 and f sub yx, and they must equal. F sub x equals 2x sine y squared, and then f sub x y. So you take the derivative for this function with respect to y, and you get 4xy cosine y squared. This is the derivative. We are going to take the derivative for this function with respect to y. So here 2x is a constant. 2x is constant. A derivative of sine y squared is cosine y squared times derivative of the angle, and the angle is y squared. Its derivative is 2y. That means here we have 2x times 2y times cosine y squared. So it is 4xy cosine y squared. And if you find f sub yx, first we are going to take the partial derivative with respect to y for this function. It is 2y x to ja x squared 2y x squared times cosine y squared. This f sub y. Then if we take another partial derivative for this function with respect to x, so f sub yx equals 4xy cosine y squared. Look, we got the same. These are the same. That means f sub xy equals f sub xy equals f sub yx. Why? Because the function is continuous. What? Huh? Doing it not. F sub xy equals f sub yx. Since the function is continuous at all, so f sub yx equals f sub xy. That's it. And then for third section in this chapter, we have total differential. We have total differential. We say, let's say it be a function of xy. If x increases by delta x and y increases by delta y, x increases by delta x and y increases by delta y. Then z will increase by delta z, and delta z is f of x plus delta x and y plus delta y minus f of xy. This is the increment of z. This is the increment of z. ليرة الرجي أو قراني كل زيت الرؤيات كانت كإكس واك أقورن بريتيلا شي بريتيلا دوزينوي f of x plus delta x y plus delta y ناقص f x y واتا النقشة بتشني كلي درجين أو كامينته بريتيلا الرجي قراني. And here f sub x is approximately equals f of x plus delta x and y minus f of xy divided by delta x, and also f sub y approximately equals f of x plus x and y plus delta y. Look, for f sub y we have y plus delta y, and for f sub x we have x plus delta x, and others the same. No, you don't need to memorize this. Only the last equation here you should know. You should know only this one. We use this one for finding the total differential. It's the calculation of obtaining this. Okay, so here I'm going to leave that one because proving and deriving the rules are not required from you. So only the rules, you should know the rules, and that's all. And you should know how to apply the rules. Two examples. Here we have this definition and says if z to be this function, to be a function of x and y, and also f sub x and f sub y exist, if these two partial derivatives exist, and if delta x and delta y are increments of x and y respectively, then the approximate increment of delta z and delta z of z is given by this equation. Here, delta z means increment of z, delta x increment of x, and delta y is increment of y. We just replace delta y by dy, okay? Delta x by dx, delta z by dz. That means here, the increment in z, is df is also equal to f sub x times dx plus f sub y times dy. What are dx and dy? Dx and dy are the change which we have in the values of x and y. These are the increments of, this dx and dy are the increments of x and y. In the example, it will be clear. And for three variables, this is the same. dw, increment of w, is f sub x dx, f sub y dy, f sub z dz. That's all. Okay? If we have more variables. Here you have two examples. In the first example, we have given this equation. Z equals f of xy, which is 3x squared minus y squared. 3x squared minus y squared. It says use the total differential to approximate the change in f of xy. What's f of xy? It's z. Here we should find the approximate change in z. That means we should find dz. As xy varies from the point 1 and 2 to the point 1.01 and 1.98. Here, from these 2 points, we can find dx and dy, changing in x and changing in y. Dx and dy means the increments of x and y. So here we are going to find the change in x and change in y by using these 2 points. We have given these 2 points. Here x is 1, and here x becomes 1.01. How to find dx? We say it is 1.01 minus 1, which is 0.01. This is dx. And dy equals 1.98 minus 2, which is minus 0.02. I'm gonna write down it again and down, but here it's just to explain it or how to find dx and dy. These are dx and dy. So here, from this example, what's given? We have given equation z. Okay. Let's write down the given things. Z equals f of xy, which is 3x squared minus xy. What should we find? Look, we should use total differential to approximate the change in f of xy. What's f of xy? Which is z. Okay, so we should find the change in f or z. So what's df equals dz equals what? We should find this. So what else is given? We have given xy is from 1 and 2 becomes 1.01 to 1.98. Okay, that means x is changed from 1 to 1.01 and y changed from 2 to 1.98. So from these 2 points, we can find dx and dy. I mean, change in x and change in y. So here we say dx equals 1.01 minus 1, which is 0.01. This is dx. How about dy? dy equals, we always subtract the original one from the changed one. Okay, that means here we are going to say dy is 2 minus 1.98 minus 2, which is minus 0.02. Is it? This is dy. So here we write down dy is 0 minus 0.02. So now we have dx, dy, and f also. We should find dz. We say dz is f sub x times dx plus f sub y times dy. This is given, which is 0.0, and it's also given, which is minus 0.02. We can find f sub x and f sub y. We can find f sub x and f sub y. At which point? At the original point. The original point is 1 and 2. Okay, so here we should find f sub x and f sub y. Let's find it. F sub x equals what? Here we are going to find the derivative of this function with respect to x. So we get 6x minus y. And then we should find f sub y also. What's f sub y? F sub y is only negative x. Yes. And now what's f sub x at the original point? What's the original point? It's 1 and 2. Is it? The values of xy. This is the original point, and this is the changed one. Okay, it's changing to 1 is changing to 1.01 and 2 is changing to 1.98. Look, when we take derivative with respect to y, 3x squared is constant. because here in this term we have no y. That's why its derivative is 0. So derivative for the second term is only negative x. And f sub x at 1 and 2 equals what? F sub x at 1 and 2, we just replace x by 1 and y by 2. We get 6 minus 2, which is 4. And f sub y at 1 and 2 is minus 1. This is, we only have x here, minus x, we just replace x by its values, minus 1. Now, we say dz, which is df equals to f sub x at 1 and 2 dx plus f sub y at 1 and 2 dy. We now have f sub x at the point, f sub y at the point. And you also have dx and dy. We just replace their values. We get it equals, what's f sub x? F sub x is 4 at the points 4 times dx. What's dx? Dx is 0.01 plus f sub y is negative 1 multiplying by, what's dy is minus 0.02. So the result is 4 times 0.01 is 0.04 plus here negative times negative is still negative, is positive, and we get 0.02. So dz equals 0.06. This is the approximate change in y. This is the approximate change in y. Okay. Here, you just need to use these rules. I mean, this one. For functions of 2 variables, you just need to use this function, this equation. And also for functions of more than 3 variables, we use this equation for solving. Here we have another example. In the second example, we have, let's take a break. After the break, we'll try to solve it. Okay. In the second example, we have let the measurements of a cuboid vary from 9.64 centimeters to 9.02, 5.97, and 4.01 respectively. That means 9 is changed to 9.02. 6 becomes 5.97. And also 4 becomes 4.01. Okay. We should use the total differential to approximate the change in volume. So here we should know what's a cuboid, and we should know what's the rule of finding the volume of a cuboid. Let's first draw the cuboid here. This is cuboid. Okay. This is a cuboid. Here it says this side is 9 centimeters. This side is 6 centimeters. And this side is 4 centimeters. Let's originally have these lengths. We let the height to be x, the length, I mean the width to be y, and the length to be z. for solving this, we should use a variable for each of the distances. Here we say we let this length to be x, width to be y, and height to be z. May someone else use z for length? It's okay. Okay. We say the height is z. That means z. So x, y, z is the height is 4, the width is 6, and the length is 9. It's changed to 9.01, 5.97, and 4.01. Is it? Yes. Look, that means x is changing from 9 to 9.01, and z is changing from 6 to 5.97, and also z is changing from 4 to 4.09. Sorry. Let's write down dx, dy, and dz. So dx is what? What's dx? We always subtract this from this. 9.01 minus 9 is 0.01. How about dy? Minus 0.03. Is it? It's minus 0.03. Yeah. Because if we subtract 6 from 5.97, we get minus 0.03. And dz equals 0.01. These are dx, dy, and dz. And we should write down the rule for finding the volume of a cuboid. The volume of a cuboid is multiplying length, width, and height. Multiplying these to each other, we get the volume. So we let the volume is be V. That means V equals X times Y times Z. Okay. In the example, we have given that we have a cuboid, and the measurements are changing from 9, 6, and 4 to 9.02, 5.97, and 4.01 respectively. We should find the approximate change in the volume by using the total differential. So here we should write down the rule for finding the volume of the cuboid, which is multiplying all measurements. It's X times Y times Z. And you have dx, dy, and dz. You can find them by from the given values. From the given values or from the given measurements, we can find dx, dy, and dz. So here, what should we find? We should find changing in volume. Volume is V. That means changing is in volume is dV. So we should find dV. In the function, this is a function of 3 variables. We say V equals f of x, y, z, and it equals to x times y times z. And here we say dV equals df, which is f sub x at x, y, z. What are x, y, and z? We use the original values for x, y, and z. What are them? They are 9, 6, and 4. The values of x, y, and z before changing. So x is 9, y is 6, and z is 4. That means here we are going to find 9, 6, and 4 times what? Times dx plus f sub y at the point which 9, 6, and 4 times dy plus f sub z at the point 9, 6, and 4 times dz. We have dx, dy, and dz, but we should find f sub x, f sub y, and f sub z at the point. We have the equation. The equation is x times y times z. Let's find f sub x, f sub y, and f sub z. Here, f sub x is what? F sub x is yz. Is it? F sub x is yz. F sub y is what? Xz. Because here we take the derivative for this function with respect to each variable. If we take the derivative with respect to y, x and z are constant, and the derivative of y is 1. We get only xz. Vale. Vale. همیشه اگر variable بالنسبة هر variable data شو ولا جديد بو أواني تحسابي رقم.
Only if it's with a variable.
vale. تنها data شو بالنسبة أول يمكن تنها أو variable كdata شو كي بالنسبة دورك. So f sub y is xz, and f sub z is xy. So what is f sub x at the point? At the point 9, 6, and 4. Here, the point is x, y, and z values. X is 9, y is 6, and z is 4. In f sub x, we have only x and y and z. In f sub x, we have only y and z. So we just replace y by 6 and z by 4. So you get 6 times 4, 6 times 4, which is 24. That's it. And now to find f sub y at the point 9, 6, and 4. We replace in f sub y, we have only x and z. We replace x by 9 and z by 4. We get 9 times 4, which is 36. And f sub z at the point 9, 6, and 4 is here. In f sub z, we have only x and y. We multiply x by y. 9 times 6, which is 54. We have these three values for f sub x, f sub y, and f sub z. We now have dx, dy, and dz. We also have f sub x, f sub y, and f sub z at the point. We just replace them into the equation. This into the equation dv. We are going to replace them into this equation. And we get dv equals f sub x. What's f sub x? Is 24 times what? Times dx. Dx is 0.01. We found this before. Plus f sub y is 36 times minus 0.03. This is dy. dy is minus 0.03. And dz is 0.1 plus f sub z is 54 times 0.01. And let's calculate this. dv equals to us. We just calculate this. 24 times 0.01 is 0.24. 0.24 plus 36 times minus 0.03 is 1.08 minus 1.08. And then 54 times 0.01 is 0.54. We now calculate this. Here we have 0.24 plus 0.54 is 0.78. It is 0.78 minus 1.08, which is 0.3, is it? Minus 0.3. So changing in the volume is minus 0.3. That means the volume is reduced by 0.3. Okay, this is the approximate change in dV in the volume. بس لو كاتا بس او كاتا بلان اگر شان رقمي كشفا واحد بغير كان يدرس. Okay, so here we used total differential for finding the approximate value for the volume of the cuboid. Is that easy? Okay. Now we have the errors. We say we let z to be f of xy, then delta x, delta z equals approximately equals f sub x dx plus f sub y dy. Here, delta z is the error in calculating z. Also, the absolute value of delta z is the maximum error. Delta z over z is the relative error. Delta z over z times 100% is the percentage error. Delta z over z in an absolute value multiplying by 100%, it is the maximum percentage error. So here, if we want to find, let's say, the percentage error. If you want to find the percentage error for the volume, we say V equals X, Y, and Z. We just apply one of these to one of the above examples. V to be X, Y, and Z. dz equals to what? dz equals minus 0.3. This minus 0.3. And this is delta z actually. dz and delta z are the same. So to find, the point is 9, 6, and 4. We first should find the volume. We should first find the volume. So the volume V equals 9 times 6 times 4. It equals 216. That's it. 9 times 6 is 54. Times 5 is 216. So here, yes, for the relative error, if we want to find the relative error, what we say? We say delta z over v, delta v over v here. This is v, because here we found dv, that means it's delta v. So the relative error, delta over v equals what? We said the volume is 216. We say delta is minus 0.3 dividing 216. This is the error. Okay, this is the relative error. Just divide this 0.03 by 216. You get the result. How about the percentage error? How about the percentage error? If you want to find the percentage error, what we say? We say it equals dv. Here in this example we have dv, but in the above one we have dz. Okay, with delta z. For percentage error, equals delta v dividing by v times 100%. We say it equals delta v is minus 0.3. 0.3. Dividing by V is 216. Multiplying by 100%. You'll get the results. So what about the maximum percentage here? We just take the absolute value for this one and then multiplying by 100%. That's all. Here, these rules are applied to the results that you get. These rules are applied to the results that you get in changing something by using the total differential. Okay, in the above example, we said it's 0.06. So here we say dz equals. And what's z here? What is z here? Z is the value of the function at the original point at 1 and 2. Z is 3 times 1 squared minus 1 times 2. Okay, it's 1. So that's how to find the errors for the above examples. Here, there is no examples actually about this, but I just applied these rules to one of the above examples. Now we have chain rules. Sorry? خش قرن تريك نازل يدور بسام بشي وسر حساب السامة وبفرها ليرة بودوز نوم إيراني كهمانا شي بكارين أول جامانك دست كانك بكارين هسه بو example يكم بو example يكم دي زيت شنو دلتا زيت 0.06 وانيا أي زيت شنو زيت خوي شنو زيت بريتيلتي value function كا لا original point كا original point كا شنو يكودو سيكا original point كا ل example يكم شنو يكودو وات x كا y دو باشا اگر evaluate function بين لو point شنو كات اكاتي 3 ضرب 1 دوجا ناقص 1 ضرب 2 لجي x ثاني لجي y دو دان ام بوشي بوزيت كواتا عمليه كاتا شنو كاتي ونيا 3 ضرب 1 دوجا ناقص 1 ضرب 2 كاتي كواتا زيت شنو ليره زيت يكا نرخي نقشه كبوشي هدوس كواتا ليره بو example يكا زيت كم شنو يكا هل يكا لمعنى دواب كده توين بيسي زيت ما هي دلتا زيت شو هي طبعا فلان بو example دوم في ودلتا في معنى okay now we have chain rules. If we have two intermediate variables and two independent variables, we say if z to be f of u v, z is a function of u and v, and each u and v are functions for x and y. As you see here, u is a function of x and y, and v is also a function of x and y. Each of these is a function of x and y. And if you want to find the derivative of z with respect to x or y, in the function of z, we have no x and y. But if you want to find the derivative of z with respect to x or y, we should use chain rule. We should use chain rule. Here, let me explain in as a tree. Here we have z. In z, we have u and v. And in u, we have x and y. And in v, also we have x and y. If we want to find the partial derivative of z with respect to x, or partial derivative of z with respect to y, what should we do? We should use chain rule. What's the chain rule? You always can use this tree to not forget the rules. We say we take derivative of z with respect to v multiplying by, for example, if you want to partial z, you want to find partial z by partial x. In z, we have no x. So what we do? We are going to find partial z by partial v, and then partial v by partial x. Look, partial z by partial v, multiplying by partial v by partial x, plus we are going to do it for all variables in z. Then partial z by partial u, plus times partial u by partial x. We have only u and v in z, so you take the derivative for z with respect to u, then u with respect to x, and also for v. This is the rule for partial z by partial x. How about partial z by partial y? We do the same, because here we have x and y in u and v, so we must use chain rule to find partial z by partial y. Look, here we have y. How to get y? How to get, we say partial z by partial u times partial u by partial. We can get y from u. So we first take partial derivative with respect to u, and then we multiply it by the partial derivative with respect to y. I mean partial derivative of y of u with respect to y. And then for v also, we say partial z by partial v, multiplying by partial v by partial y. These are the rules. Okay, is that clear? Let's take an example and it will be easier. Here we have z, which is a function of u and v. We have z, which is a function of u and v. And u is a function of x and y. And also v is a function of x and y. That means here we have z is a function of u and v. And u is a function of x and y. V also is a function of x and y. How to write down the chain rule? How to find partial z by partial x? Since in the function of z we have no x, we have u and v. But in the functions u and v we have x. So we use chain rule. How to write down the chain rule? We say partial z by partial x equals partial z by partial u times partial u by partial z. Partial z by partial u times partial u by partial z. دين داتا شاب بالنسبة أو variable كلنا x زتا ولكن أنجا داتا شاب أو variable يعني كلنا زتا بالنسبة أو جوراو كأمير ويو بدوس ببرأو x. Then plus بهر variable بجاي كم هو plus. حتى again بو variable كداتا شاكي ولا جين سمناه داتا شاي زي بالنسبة x ولا شلون بجنب x؟ للرجال u جنب x. فحتى داتا شاي نقشة بالنسبة u ولا بجنب أنجا u بالنسبة x ولا بجنب. Okay. Plus partial z by partial v times partial v by partial x. بالنسبة إما partial z by partial x. Vale. Lavare partial z by partial z x addition. فهذا بيحب بالنسبة x only. Okay. This is the channel for partial z by partial x. How about the channel for partial z by partial y? We say partial z by partial y equals what? Tell me. How to get y? You can get y from u and v. So you say this times partial u by partial y plus partial z by partial v times partial v by partial y. That's all. Okay. These are the chain rules for partial z and partial x. Let's find their values. So here, what are the partial derivatives that we have in partial z by partial x. We have partial z by partial u by partial x, partial z by partial v by partial x. It's easier if you find them all and then just substitute them into the term. Let's find them. Yeah. We say partial z by partial u equals to what? What's partial z by partial u? We are going to find the partial derivative of z with respect to u. This is z. So what's the partial derivative of z with respect to u? That is how z with respect to u here. V squared is 0. So you get 2u. And partial z by partial v equals to what? 2v. Yeah. And then what's partial u by partial x? This is u. If we take the derivative for this function with respect to x, what we get? It's 2xy. Since y is a coefficient, it's not a separate term. Yeah. Here we get 2xy. How about partial u by partial y? We should find all. It's only x squared. If you find the derivative, partial derivative of this function with respect to y, we get only x squared. Because here, x squared is the coefficient of y. But if we have x squared plus y, at this case, we say it's 1. Yeah. Yes, it's only 2x. If you have two terms, if you have a term with no x, when we take partial derivative with x, that term is 0. But both is one term here. X squared and y, they are multiplied, so it's one term. Y here is the coefficient of x squared when we take derivative with x. And when we take the partial derivative with y, x squared is the coefficient. Then partial v by partial x. What's partial v by partial x? This is v. This multiplication of x squared and cosine y. So cosine y here is constant and it's coefficient of x squared. If we take partial derivative of v with respect to x, we just take partial derivative for the function. I mean, we just take derivative for x as 2x cosine. Yeah.
It doesn't go away.
ناروات لبن أو يصير كان إما كاترين سي إكس دوجا سي كأروات واحد بلا عقب ما وتا سي زائد إكس دوجا أو قال سي كا it's the same. And then for finding partial v by partial y, it equals to what? And x squared is coefficient, so just write down the same. Then derivative of cosine y is minus sine y, and derivative of the angle is y, it's still 1. So it is minus x squared sine y times 1. This one is derivative of the angle. So it's still minus x squared sine y. Now we replace these into the chain rules. For partial z by partial x, what's the result here? See, partial z by partial x, it equals to what? It equals to partial z by partial u. So what's partial z by partial u? Here we found this, it was 2u times partial u by partial x. This is u by x, which is 2xy. Plus then partial v by partial z by partial v, it is 2v times partial v by partial x. So here partial v by partial x is 2 cosine y. That means partial z by partial x equals 4xyu plus 4 cosine y times v. But here, u and v are functions of x and y. We just replace them.
So dx plus 1, dv is dx.
dv over dx is 2x cosine y, yeah. Because here we have x squared cosine.
Then we have to do cosine.
Yes, that's 2x, sorry. dv over dx is 2x. So it's 4x cosine y. We have this. And u and v, we must have only x and y in the results. We must have only x and y in the result. Here, we have u is x squared y. That means we replace u by x squared y. And we replace v by x squared cosine v. Cosine y, sorry. We replace v by x squared cosine y. In the result, we must have only x and y. So here we replace u by x squared y and v by x squared cosine y. Let's do it. That means partial z by partial x equals 4xy times u is x squared y plus 4x cos y. V is x squared cosine. That means it equals partial z by partial x equals, here we multiply these, we get 4x cubed y squared. If we multiply these two, we get that. Then plus 4x times x squared is 4x cubed. Cosine y times cosine y, cosine squared of y. This is the result. This is partial z by partial x. Okay. So here, the most important thing here is using this tree to write down the chain rules and then write down all the derivative that we need in the chain. That's all. Just substituting and that's all. Then at the end, in the result, we must have only x and y. If you have u and v, so u and v should be given in the example. We just replace them by their formula. So we get partial z by partial x. How about partial z by partial y? We just here we found all the derivatives. We just plug in these to them. We get the results. It's the same. This for two intermediate variables. But for three intermediate variables and three independent variables, how to write down the partial, the chain rules. Here we say W is a function of U, V, and R. And each of these, U is a function of X, Y, Z. V is a function of X, Y, Z. And Z, R is a function of X, Y, and Z. If you want to find partial W by partial X, in the function of W, you have no X. So you must use chain rule. We have Z, sorry, W. We have W. In W, we have three variables, which are U, V, and R. And in each of these functions, we have, in each of these functions, we have three variables, X, Y, and Z. X, Y, and Z. X, Y, and Z. Look, X, Y, Z. X, Y, Z. X, Y, Z. So how to get partial W by partial X, or partial W by partial Y, or partial W by partial Z? We do the same as we did before. To get partial W by partial X, we can get X from U, V, and R. That means we say it's partial W by partial U multiplying by partial U by partial X plus partial W by partial V times partial V by partial X plus partial W by partial R times partial R by partial X. This is the chain rule for partial W by partial X. How about partial W by partial Y? We do the same. Here, to find partial W by partial Y, we can get Y from U, V, and R. That means we should use chain rule. Partial W by partial U times partial U by partial Y. Then partial W by partial V times partial V by partial Y. And then partial W by partial R times partial R by partial Y. This is the chain rule for partial W by partial Y. How about for Z? It's the same. It's the same. Okay. That means it's better to draw this tree to get the chain rules. Okay. Always draw the tree and then write down the trees. You'll not get, you'll not take a mistake. Here we have an example. It says, okay, the example for next week